introduce myself and then the topic, and I would give a brief introduction for Chris, and then we can take it over from there. So I'm Garima Bajpai, the founder of the community of practice in Canada. We have three chapters here in Canada: Toronto, Ottawa, and Edmonton. We also are the organizer for the DevOps Summit, which happens in Canada. And I'm also associated with DevOps Institute and Continuous Delivery Foundation as an ambassador. I also have co-created continuous product-oriented practice, which is directly linked to how we see and decipher data with the product strategy. We have the products which we are building up as we see in the next era. So this topic is really interesting for all of us to understand. And I would like to thank Chris, who is the CEO of DataKitchen, who has accepted this invite to talk to us in this community of practice and give us insights around the origin of data ops and how data ops is different from DevOps, or is it just DevOps for data? We also will ensure that we have key takeaway and learnings from DevOps and what Chris would let us know about his findings around data ops and the distinct challenges which data ops brings to us. What kind of distinct upskilling which we need for organizations, individuals, and teams. And lastly, the Data Ops Manifesto. It's very interesting that DataKitchen has come up with the Data Ops Manifesto, and I was reading through this manifesto before the session. So I would call upon the community of practice to have a look at that manifesto and see if you could support this manifesto through the community of practice. So again, I welcome Chris. Thank you very much for joining today. Before you start your session, I would like to let all of us know that this session is recorded and would be available for online community at a later point of time. So welcome.
Oh, thank you. Yeah, thanks for the opportunity. And let me, I prepared some slides. So let me share my screen and kind of talk about the presentation and do that sort of talk about my background and what we're going to talk about today. So, and thank you for that great introduction. So my name is Chris Bergh. I am engineer, software engineer by training, sort of got into the analytics field about 15 years ago, still very technical. And so I want to talk about my journey and how I sort of arrived at data ops and sort of what it is and what we talk about. And this presentation is really meant for people who come from a DevOps background. And so it's titled, Your Data Nerd Friends Need You. And so the idea here is there's a lot of things that have become accepted practice in building software-based transactional IT systems that just don't exist in the world of analytics. And I think they need to, and how these principles can be applied. And so I'm going to talk through that story, and in some way, it's my journey. And so, can you see can you see my full screen, or I think so. There you go. And so, if we think about it, like super broadly speaking, the sort of technical IT systems that we create on the left-hand side are transactional systems. And so think of those as like a 3-tier application talking to a database, persisting data. So maybe it's your ERP system or your CRM system or an order form system. And those in general are built with DevOps principles around iterative development, around automated testing. And this wasn't always the case. And so in my career, I was a software engineer starting about 1990 and worked at companies like MIT Lincoln Laboratory and NASA, and then startup companies, and then Microsoft. And we did a lot of sort of throwing stuff over the wall, a lot of manual activities, and the sort of Agile Manifesto came out in 2000, and sort of DevOps came after that. And so now it's sort of, if you're going to build software and build a transactional system, you should follow DevOps. If not, something's wrong. And so if you look at analytic systems, and those are systems that primarily don't take user interaction, but they primarily about aggregating data from different sources and creating value from it. And they're kind of stuck in the dark ages. And so there aren't really any accepted principles. And there's sort of a lot of bad engineering practices that go on. And that's sort of what we started to set out to do in the company. And the reason for that is sort of my own personal journey, because after working and managing software teams and delivering software, I thought I'd kind of, in 2005, I thought I would join the easier world of data and analytics because my kids were small. And I thought, oh yeah, this data stuff, it's simple. And it turned out it wasn't simple, and it was actually pretty hard. And it was hard for a bunch of interesting reasons. Not that it was hard in the sense of like running algorithms on data is hard or doing ETLs hard. It was the sense that stuff kept breaking, and when your data is wrong, people would call you up and yell at you, or when you weren't going fast enough, people would shame you for being too slow. And sort of managing teams of data scientists and data engineers and people doing data visualization, my life sort of sucked for many years because I just trying to deliver these analytic systems was really hard. And so I had to sort of go back and think from first principles on how you actually do that. And so in some ways, this idea of data ops is sort of my 15-year journey to do this. And we started a company 7 years ago focused on this, but it also is my experience for 7 or 8 years running teams doing it. And so the agenda is really to talk about the problem and really to talk about what's wrong with delivering these analytic systems, and really to try to get you to have some empathy for these people, and mainly because they're sort of suffering in some ways, and they're sort of stuck in the dark ages, and a lot of things, these principles that come from Agile and DevOps and automation, infrastructure as code, can help. And so, over the past 5 or 10 years, these words about big data or AI or machine learning, it's the data lakes, data warehouses, it's like a buzzword. And what's interesting for me is when I started to do data and analytics in 2005, I sort of had to explain it to people. It's like, what do you do? And I was like, oh, I have a team that produces charts and graphs. And they go, oh yeah. And now you can't escape analytics, right? It's in football games, it's on TV, it's people are looking at, the literacy of data has really increased, which is great. And it's actually a huge market. It's 189.1 billion, and it's double-digit annual growth. And even from a startup perspective, like one of the biggest acquisitions in sort of the DevOps market history was GitHub for 17.5 billion. But one tool that does data visualization, think of it as an IDE for charts and graphs, was sold for 15.7 billion. And in some way, there are tens of millions of people creating insight from data. It's more than people who do software developers or transactional systems. Think of 1 in 25 workers who are actually creating insight from data. And so, it's a big problem. And so, what has really happened over the years is that delivery of these analytic systems, whether that you call them data science or a data warehouse or charts and graphs, most of them actually never get into production. And companies that are calling themselves being data driven, which is kind of if in IT systems, being digital transformation is sort of the highest bit. This is really data driven is the highest bit in data and analytic systems. The number is going down, and a lot of projects fail, and a lot of projects have errors. And so there's a whole bunch of reasons for that. But one of the dirty secrets of data and analytics, and if you talk to people, is that it's failing, and it's kind of failing for an interesting reason. Now, I grew up in Wisconsin in the 70s and 80s. I wasn't a hockey player, but in some ways, data and analytics is producing cars like a Wisconsin-based company, American Motors, in the 1970s. They produced this car called a Pacer, which was just a terrible car. It didn't last very long. It had a lot of problems. And in like the 80s, 1980, my dad, who worked in a union, drove a Toyota Corolla, which was, a lot of his union buddies sort of busted on him for driving a Corolla. But my dad said, yeah, it's cheaper and it lasts longer, so why wouldn't I buy it? And so, why does Toyota go on to be one of the biggest car manufacturers in the world and American Motors out of business? And it's this idea that, the process in which we work, sort of how you do things as opposed to what you do, is actually important. And that sort of lean process sort of started in manufacturing and went through software. And we're sort of trying to bring that to the world of data and analytics. Because today, most organizations are kind of caught in this if they're focused on process at all, their cycle time to deploy new data models, new data sets, new data transformations is really slow. And then they have a lot of errors, or they don't even know how many errors they have. And there's a lot of problems in collaboration that I'm going to talk about in the different roles, and a lot of challenges with process measurement. So let me kind of go through, and some of you, everyone probably on this call knows someone who does sort of data science or data engineering, or has maybe done some of it itself. But I want to talk, first of all, just about the people. And so what I've noticed is that people who do data and analytics, they sort of talk like people who do software and IT. They look like you, but somehow early in their career, they took a left versus a right. And they accepted that job offer. Instead of building a transactional system, they started to build an analytic system. And there's thousands and hundreds of thousands of people that do that. And they have these people and process problems that the perspective of a DevOps community can help. And so let's talk a little bit more about those people. And so there's different roles. So the first role is someone called a data engineer, and he or she may access data and integrate it, put it together for people. There's people called an analyst who sometimes build charts and graphs. There's a data scientist who apply algorithms to data. There are statisticians, which is a variation of a data scientist. There are managers, administrators. There's a whole bunch of people who work with data. And they all follow this sort of similar pattern, right? There's transactional systems sort of on the left, and you pick your type: CRM, ERP, supply chain, website, financial. Sometimes there's syndicated data. They get it through databases and APIs. And then they pull it with some frequency, either streaming or batch, and then they get insights, charts and graphs, ideas, reports. And sometimes there's actually a loop back to the transactional system where people create an insight and it goes back into. But in general, it's a separate path. And so if you look at it from a human standpoint, these people work in teams. There's a data engineer, a data scientist, someone who does data visualization or self-service BI, and I'm going to talk a little bit about that, someone who does data governance and production operations. And there's sort of a massive fragmented tool chain in that $100 billion market. So if I'm going to be a data engineer, I've got 50 different tools to choose from, some of which help me in process transform data, some of them using that's called ELT, some of them are called ETL, some of them actually doing a database that's called ELT. There's different languages. There's lots of tools to visualize data. There's been an explosion in the past 5 or 10 years of tools to do data science or AI. There's a bunch of tools to catalog data to say where it is. And there's, as you know, a bunch of databases. And if you look at the craziness of, for instance, a company called Snowflake, which makes us a database that is specifically built for analytic systems, that is worth something like 150 times revenue, which is a crazy valuation. These are big companies that are making tons of money or valued a lot. And so let's talk about a scenario just to level set. So let's say I'm a data engineer, right? And I get some data. Maybe I get it from one of those sources that we talk about, and maybe it's sales data, right? And there's a name, and there's a name column and a sales column. So I get that data, I extract it from perhaps Salesforce or SAP. If I'm in the cloud, it goes into a bucket store like S3. And then I put it in perhaps a database like Snowflake, and I create a database table. And so this table is part of what the data engineer does, is to make sure that this data is right and that it reflects what's currently in the production systems. Now, there's another person, and this is a really simplified example, and she's a data scientist. And so she's going to go look and say, well, how do I group these people together? How do I segment my customers? And so she creates an algorithm, a Cahonin cluster, and a bunch of if then else statements. There's tons of ways to do it, but says, okay, here's a high value segment and a low value segment. And that's another column in the database. And there's different ways. There's a simple batch way. There's real-time ways of doing it. But now I go to the next group. And so there's this group called data visualization or self-service BI. And so there's and we're going to talk about this, there's a lot more sort of citizen developers, low-code development tools that are used. And sometimes that one called Tableau, where they actually go in and visualize it. And then there's tools that actually help people. They're called self-service tools. So there's someone who maybe doesn't have a CS degree, be able to pull some lines and prepare data. And a lot of times they're going to visualize it, and sometimes they're even going to add data into it. So like in this case, it's who owns this customer. Maybe it's the West team or the East team, and they add that in. And so these tools are, they're pretty common. And then the last part, or the second to last part, is something called data governance. And if you've done, it's similar to governance in IT, but the role of data governance is kind of sometimes to do something called metadata, where they're going and saying, okay, this column came from the raw data source, this segment came from data science, this owner came from somewhere else, and they're trying to catalog it and discover the lineage. And so all these people are kind of involved in doing the work, and then there's production operations. Now, sometimes data and analytic organizations have hero modes, and there's one person that does all this, right? And that's fantastic, right? But what's happened in the explosion of interest in data science and data engineering and AI is that it's become much more of a team sport. And it's very common to have teams of 50 to 100 to 400 to 500 people, or thousands of people doing data and analytics in an organization with sort of titles equivalent to this. And what's also interesting is that these teams are functionally aligned. So the data engineers may have their own development process, and then the data science may have their own development process, and data visualization may be working without a development process. They may be just configuring a tool, data governance and production. And so each one of these teams is kind of operating most likely functionally independent. And sometimes they're grouped together, but a lot of times they're kind of grouped into sort of centralized and decentralized teams. And they sometimes even have different bosses. So there's a role that's come off of called a chief data officer or a chief data and analytic officer. And they all sometimes work for that person, but oftentimes not. They can work for different people. And then they can have different parts of the organization. And so if we look at one that's gotten a lot of publicity, the sort of data and AI cycle. And one of the interesting things about building analytic systems is in building software systems, you're trying to get something in the spirit of Agile and DevOps, you're trying to get something in front of your customer quickly to get feedback and to see if it makes sense and then improve. And you're trying to do that with data and analytics, but you've got another side to the problem. It's more of a dual side. You're also trying to see if the data itself can express things that your customer wants to see. And so a lot of times you think the data is going to say something, but it doesn't. And so people in data science are often trying to find out if the data tells something by applying a predictive model, a segmentation, a cluster, a prediction to that data. And so they have to go through this process of sort of pulling data out, seeing if it makes sense, preparing it, building a model, and then evaluating the model about whether it predicts, and then deploying the model. So they have this sort of double-sided problem that actually makes it hard. In fact, all of analytics, whether you're looking at it with an algorithm or just trying to understand data, you've got to figure out if the data makes sense first, and then you also have to get it in front of your customer. So you're kind of working both angles. And so let me, I'm kind of talking a lot here. Just want to make sure if I'm not missing any questions. So yeah, and people feel free to jump in. I hope this is going good so far. So if we talk about this in a kind of a technical way, so most data and analytics systems have this picture where there's some source data on the left, and then there's the data customer on the right. So I get data from a CRM system, it goes off to the VP of marketing. I get data from my sales system, my ERP system, it goes off to the CEO and the production line, and stuff happens in the middle. And that's, in general, these roles of data analytics or engineering and science. And the way I use the term data and analytics is kind of the big superset. It says all this stuff, whether you're modeling or visualizing data. And for most organizations today, they kind of actually, if they're big enough, their default way is to work in a sort of a waterfall method. What they do is they'll get requirements, they'll put together some data, they'll have a model on top of it, they'll have governance, it's slow, it's waterfall, and it takes months to deliver. And mainly because, and it's a real question on why they're not doing it in an agile way. And I think that's, you're going to see this comes out, but it also, it comes from the double-sided problem of data, right? You're trying to figure out if the data makes sense and if the customer, how you can express that to the data and also just comes from, I think, a lot of fear that people have of making things wrong. And because in my experience, and one of the reasons why I'm trying to sensitize people who do DevOps to this is that data and analytic teams are sort of beaten up. And when they get data wrong, it has sort of a pit in their stomach. And there's so many data and analytic teams that have the life I had in 2007. They're going to work in the morning and they're just waiting for the email for something to go wrong. And they have no idea if the data that they got that night actually is going to work, if something's going to break, and they're just sort of living with this fear. And partly it's because they follow this waterfall process. And one of the things that we're trying to do, very similar to DevOps, is we're trying to get them to work in an agile way. In fact, if they work with Agile or Scrum or Kanban, however, the processes that you do to manage a software team, the human processes using Jira and tickets, story points, burn down charts, those things I think actually really apply to data and analytics. And so just getting a team to work in an incremental way, deliver short bits of value, I think is important for people to being successful. And then, as I said, a lot of people who work in data and analytics, and this is a survey we did with an analyst group called Eckerson a few years ago, they just have a lot of errors per month. And sometimes they don't even know. And so I talked to one healthcare organization. They were really proud that they were down to one major data error a month. And that's just, to me, that's just unacceptable. Because what happens is, and the way this ends up for the customers of data is they stop trusting it. And if the whole point is to help your organization to be data-driven, is to help the business customer, the people who are receiving the value of the data, trust it. And if you're having errors all the time, not only does it make your end customer distrust the data and not be data-driven, it's just a pain for the team. And you're going to see why it's a pain. And one of the one of the biggest ones is this idea that thinking about how you do your work as kind of a factory. And so if you think of the process of building data, so I get data from outside and I bought all these tools. I have a database that I put the tool in, right? It could be Redshift or S3 or SQL Server or Snowflake. And then I want to transform the data. And there's tons of companies that do Informatica or Talend or Airflow. There's data science tools like Python, SAS. There's data visualization tools like Tableau or Cognos. And then there's catalog tools. And you can kind of think of these as, imagine a car factory, and each one of these sort of green boxes is a place that things are assembled and data's put together. It's joined in a database. There's specific formats where the data is being represented, like a star schema. There's ways that algorithms are applied to it, data's added in, data's created, visualizations. And so you're kind of assembling a system. And so one of the things that we try to do is to get people to think about this production process, and whether it's batch or that it runs like a factory. And actually, I think a lot of lean manufacturing methods apply, specifically statistical process control is really important here, because a lot of times you want to run the system and you want to know that it's right. And you want to make sure that when you're giving a Tableau dashboard, a data file to your business customer, that you know it's right before you get it. That's an important part of what we're trying to do with data ops, is just get people to observe and test. And it's very similar to the notion of observability in DevOps. We happen to just call it testing and monitoring in production, but you'd be surprised. In fact, the majority of analytic systems out there, and this is going to freak you out, have no tests that check the data to see if it's right before it goes out. They deploy stuff into production and just kind of hope things work. And it's big companies or small, they're just not checking to see if it's right, which is just sort of shocking to me. And depending on my mood, some days I just want to pound my head against the wall. Other days I'm inspired to help people. So, and another challenge in data and analytics, and this goes back to where the teams are organized, they're not they don't work for the same people. Sometimes they don't work in the same building. And you may have a centralized IT team that's building a data warehouse or a data lake or a data enablement platform. You may have a data science team, and then you have these teams who are doing analytics in multiple lines of business. And so in software teams, you'll have maybe a front end team and a back end team and a DevOps team, right? And you got those three teams, and so it's dev and ops working together, and maybe dev's front end and back end. In data and analytics, that's sort of a smaller scale problem of what data and analytics have. So in some cases, if you go through this diagram here on the left, this sort of star means a development team, this green circle, and there's data engineers and data scientists. Maybe there's a centralized development, and maybe they have a centralized production. And so that's not as common as what's on the right, where there's this decentralized development, where maybe you have a data warehouse team or a data lake team. And in every line of business, you also have a team who's doing some data work. Maybe it's charts and graphs or some data prep, maybe it's some data science. And then each one of these can have their own path to production. And so instead of having dev and ops as kind of a one-to-one thing, you have dev and ops as a many-to-many relationship. And this is almost the accepted norm now. And that's part of the reason why Tableau sold for $15 billion, because it's a tool that runs in these sort of light green Ds. It does have the end effect of helping people get more insight to their customer quickly, but they end up doing it in a way that just causes a lot of problems. And one of the bigger problems is, as we've seen in software, the sort of Conway's law. And so the fact that and this is not a compliment to data and analytics, is that the kind of technical systems that they build or that people build are really a function of kind of the organizational structure and not an optimal way to do it. And so it reflects this decentralized right column here. And so in a lot of ways, there's a big distributed system problem underneath here, where data is processing, going through multiple servers and running through multiple systems, where you may have 5, 6, 10, 15 physical servers involved in creating a data and analytics system. And that may not be right. Not to say it has to be one server, but it's just the structure of how the data pipeline is processed is more reflective of how the teams work than an optimal way to do the system. And so if we go to the next thing, like, well, how do I fix this? And so one of the most important things in DevOps, and the idea is that you're actually thinking about the processes to build IT systems, to build software systems. So in a DevOps world, you're thinking as a first order item about deployment or testing or monitoring. And those are really important things. And infrastructure, servers, how to abstract those, infrastructure as code, and those processes. It's not about what the stuff that you do. You're thinking about a system to build the stuff that you do. And so in data, there's this sort of false belief that it's about data, so I don't have to think about the processes. And data is different, and I just sort of reject that. It really isn't about data. It's about the processes that are acting upon data. And so one of the things that we think about in the data ops world is there's sort of three processes that happen here. And one is a production process. It's that factory where data is sort of going in one side and coming out the other. And these circles mean different tools. And then there's a deployment process to take things from a development environment and get into production. And then there's a development process across all these teams. And what we try to do is guide people to start thinking about their process. And first, just think about your production process as a factory and focus on errors. And maybe your error caused because you've got poor data quality going in, maybe some new code got in that broke it, or maybe some server went down, but just lower errors and keep track of them. And one of the things that this goes also to sort of the safety culture that we talk about in DevOps. It's sort of observe your system, make sure it's right. And I think a lot of organizations are suffering because when things happen, when things go wrong, because of the nature of how their teams are organized, Conway's law, they're in different parts of the organization, you end up with a lot of shame and blame, a lot of finger pointing, and it takes a lot of time to have systems when they break be fixed. And I think it's really hard for some people. And let me just, I'm just going to switch a presentation here just to kind of give a concrete example, and maybe this will help. And so one of our customers is an American transportation company, and they had a bunch of errors, right? And they got streaming data, and just to look at an example of what their architecture looks like, right? Because there's source data on one side, there's people on the other, and they had lots of different ways. So they had some vehicles that were streaming. That means the data was coming in fast. They had sort of fast batch. They had two different methods, NiFi and Kafka. They had Informatica, which is a ETL tool, which was batch. They had predictive models all going into a data warehouse. The data warehouse goes off to things called Jupyter Notebooks for data science and Tableau. This was all on-prem. They're also trying to go to the cloud. And this system was kind of owned by different parts of the organization. There are different IT teams and handle the ingest process. They had a warehouse team, they had a data science team, an analytic team, a cloud team. And so when something went wrong, how do you know where it is? And this is, again, it's a largely untested system. So if on Monday morning, if the VP finds a problem and says, this looks weird, then they have to say, is it the chart that did it? Is it the warehouse? Is it the model? Is it the ingestion scheme? Or is it the source data that did it? Did some of these vehicles suddenly stop producing the data I want? And it would literally take them days to figure this out. And so, one of the things that we want people to do is to take and build a system on top of the system that observes it in production, that integrates to all these tools and tells you as the system's running whether it's right. Because in one case, you may have vehicles that are producing 1 million rows of records, and they've been doing it week in and week out. But this week, they only have 200,000 records. And I think you should know about that when you run a system before you give it to your customer. You shouldn't let your customer find it. And that kind of very basic statistical process control, I think, is something that needs to be done. And because teams are just spending too much time having problems. So if I go back to my other deck and talk through these processes, there's a second process, which is this deployment process. And this is kind of similar to CI and CD and data and analytics. And I'm going to talk a little bit about the differences. And the cycle time at deployment and the mean time to error in deployment, I think, is really is important. And then finally, this collaboration, being able to work across teams and just not have so many meetings. And what's interesting is you find teams who do DevOps really well. One of the things that they target is a new person joins the team. Can they fix a bug and get it into production that week, right? Or maybe even if they're super good that day that they first join. And that's not a metric that most data and analytic teams have. You'll join a team and you'll have to fish around, and maybe you get something in production in your first 3 months. So that might be a good thing. And so in a lot of ways, data ops is about automating these process cycles of the development and deployment. And so let's just talk a little bit about the idea of data ops and where it came from. And so, I think, and part of my motivation for starting the company is data people are suffering. And there's a lot of hero culture where I'm the great data scientist, I'm going to do everything. There's a lot of fear culture where I've gotten yelled at so many times, I'm going to invent a bunch of processes. There's this insanely high error rate. There's kind of a complete lack of automated testing, both in production and in development. There's deploy to production rates of months. There's lots of hope and heroism and fear. There's technology review boards. And actually, there's Gene Kim in his latest book wrote a subplot thing about Project Panther, about building the data warehouse. And I was fortunate enough to talk to him and help him sort of see this side of DevOps about data and analytics. And the term data ops itself is having a bit of a moment, right? We've been talking about it for 6, 7 years now. We wrote a manifesto, which is a blatant ripoff of the Agile manifesto, and some DevOps ideas and some data put in, just to try to get people to believe that this is part of it. And the way that we define data ops in and of itself is very similar to sort of Gene Kim's version of DevOps. And data ops is a set of technical practices, cultural norms, and architecture patterns. And it's specifically, again, for these analytic systems, for these people who do data and analytics. That's about sort of rapid experimentation and innovation. It's about low error rates. It's about collaboration across complex sets of people and tech and environments and data sets, and about clear measurement and monitoring. And so, and I think Jessica, who works with me, just put, if you want to read this chapter from the Unicorn Project, you can actually download it from our website. She just put it in the chat. So the last thing is, so what's the difference between DevOps and DataOps? And so from one angle, I think they're all kind of the same, right? In the sense that they're all ways to like have a group of people who work on a technically complicated thing, do it better and do it with more agility, more lower errors, and better outcomes for their customers. And that technically complicated thing could be a manufacturing line, it could be software, or it could be an analytic system. But there are some differences. And so first of all, it's just that people are different. There's data scientists versus a UI developer. There's data engineers versus a backend developer. And there's a different set of expectations and different tools. And I think DevOps is more one-to-one and DataOps is more many-to-many. And that's that sort of graph I showed you before. And also, I think there's a lot more sort of factory methods because of the multi-tool orchestration and testing and statistical process control. I think are just insanely important. I think DataOps, due to that, is sort of additional development complexities. And one way to talk about this, and this is just the world's worst acronym, but I like it because it's bad. So, in DevOps, you've got CI and CD. In DataOps, you've got CSMOIDM, which is, again, a terrible acronym, but I kind of like saying CSMOIDM. And so what it really means is that you're doing continuous sandboxes because the development environments in data and analytics have a much more huge data component in them. So getting test data, getting all the tool chains is actually really important. And also extends, it's not to say you can't infrastructure as code. There's continuous meta orchestration, and that means you've got to build the factory. And I also think it's very similar. CI and CD is the same, and then continuous testing and monitoring. And so I think, we think that there's just more complexities. And so one of the things that I do as a company is try to convince people who do data and analytics and are kind of stuck in full hero mode or stuck in full fear mode that these ideas matter. And they may have heard and talked to you people who do DevOps, and they may have gotten a sneer when they say to you, when you ask them, how long does it take you to deploy that model to production? He says, well, I don't. I've made 13 models this year, and only one's gotten into production, and it took 4 months. And so, I think one of the things I try to do is talk that there's a bunch of benefits. And, I think one of the biggest benefit is deployment frequency. Another is sort of production errors. And I actually think that by applying DataOps, you can really help your analytics team both be more productive and happier. And so this sort of faster, better, happier, which you hear sometimes in the DevOps community, I think really applies to data and analytics. And so another way to look at it, and another struggle, is that if you think of sort of best-in-class companies, and there's a spelling error on this slide I got to fix. And if you read some of the latest DevOps research about that have been done doing research across lots of companies, and it turns out that best-in-class people do a lot of things well in DevOps. And I think that's the same in DataOps. And what we've seen with our customers and people who are using our software is that they can deploy fast. They can deploy with low errors and run with low errors. And they can get people across different roles to collaborate, and they can measure the process. And if they do all that, they actually end up having highly productive teams and lower costs, and they have less unhappy customers. And so this idea of a graphic equalizer that you can push everything up, I think, is a really important idea, because a lot of people who've been in data and analytics for years, just taking those left two columns here, if you say, hey, you can push a lot of stuff to production fast, they're neck's going to get stiff. They're going to hold back and say, no, I'm not going to do that. I just got my system working. And you know what? I get yelled at when there's data errors, and it makes my life unpleasant. And I got to work Friday and Saturday to fix it. And so just the fact that you say you can push up on both these things, you can go fast and put new code into production, and be able to do that with low errors, is something that a lot of people in data and analytics push back at. And so, so how you can help them. So I think, first of all, I guess partly the reason I built this deck is I think there's a role for people who've done DevOps to go into this data and analytic world. I mean, I made the jump. It's cool, it's interesting, and a lot of the ideas apply. And so, I'm sort of on a mission to get more DevOps people to start joining data and analytic teams. And, just, I think another way you can do that is when you're at lunch, and you've got these people who look like you and talk like you, and maybe they're a data scientist or a data engineer. I think ask them some impertinent questions. And, maybe I'm an obnoxious nerd, but like, ask them a question. Are you using source code control for your work? How many automated tests do you have in production? Do you have regression, functional, or automated unit tests for the work that you do? How long does it take for you to deploy your model, your ETL code from dev into production? Is it automated? How up to date, how different is your development environment from a production environment? How often are your business users finding errors in the data? And if you ask these questions, you're just gonna be horrified. Because I think if you know DevOps, you're going to want, the right answers to this, right? You should use source control and automated testing and rapid deployment. And you don't want to have the people who use your stuff find problems. You know the answers to that, and you know why it's so important. And what you're going to find is you're just going to be shocked. You're going to want to, like me, you're sometimes just going to bang your head against the wall. And I think that's why there's a role for the people who've got experience in DevOps to help, because that sense that if you invest in these capabilities, you invest in how you do it and not what you do, you can actually help people perform better. And another chart I often show is this one, about just thinking about how people should work. And so one of the ideas that I talk about is if the percentage effort. And if you go across the top on this, most people right now in doing data and analytics development, there's only sort of 3% of their time, and this is my guess, but I've been in the industry for a while, so it's sort of ballparkish, are focused on solving these questions in my last one, the sort of operational ones. And now if you look at software teams doing DevOps, this on the lower left here, a study said from Dynatrace said that 23% of the team is involved in these processes of deployment, testing, DevOps related tasks. And so a quarter of your team is involved in that. And why? Because how you do it has such an importance. And because if you do the how right, you can have people deliver faster feature, you can get more done with less effort. And so I think that change in mindset, and that also goes to my experience in the software industry, because I was a software engineering manager, and back in 1999, and we had a release engineer, and he played the mandolin at parties, and we thought he was a good guy, but he wasn't as good of an engineer as the rest of us, so we thought. And we just throw the wall at him, and he'd take the installer and put it in the code on our SaaS, or our SaaS platform, and we just had a lot of problems. And you play that forward now, and a DevOps engineer is a very highly skilled, sometimes paid more than the software engineers, because investing in this little blue box, investing in the ops side, people see all sorts of benefits too. And that's sort of my mission, is I want to get people to think that way about data and analytics system. If you invest in the ops side, if you solve these sort of questions that we talked about, if these impertinent questions that you ask make sense. And so the last two things is, and then I'll take some questions. So if you want to learn more about my company or learn more about Data Ops, we wrote this sort of 18-point manifesto, one page. And if you've read some of the DevOps manifestos or Agile manifestos, you'll snicker at how we ripped it off. And then we also wrote a book called the Data Ops Cookbook that's free. It's sort of how you apply principles of lean manufacturing and DevOps. And then you can get an excerpt from Gene's book if you want. And then, of course, we have a software product that does this, and it's sort of how, it's sort of, think of it as sort of GitLab for data and analytics, or GitHub for data and analytics, or a CI and CD system plus some more stuff. And that's it. And so let me stop there. Did I take 45 minutes? Yeah, so I got just 45 minutes. And so I'm just going to, so people free to speak up, but I see one question. So the question is, you borrowed individuals and interactions over process and tools. In my experience, both are important, and often in Agile leads many to believe that process and documentation is not required. I like the idea of data ops, as there's not been a really method of help in this space, but there's also an underpinning of lean to help it be supportive. Yeah, so I'm not sure if that's a question or a comment, but like one of the things that we talk about is very common in the large companies that we serve, that data projects follow waterfall because they think they've got to do everything's got to be perfect before the customer sees it. So they've got to have it well documented. They've got to have it and document the data itself, document the charts, and document the process. And so I think those things are essential, right? Data governance is essential, and documentation is essential, but also trying to make sure that what you do actually has value is, I think, most important. And so what we try to guide our customers to do is to think about these things not as I'm building a system and the system sucks if I don't have all the necessary process and documentation. Just it's a matter of timing. Is like deliver something of value, see if it works, and then maybe the next sprint add in some documentation. Maybe next in try to work on your process or work on your tech debt. And so it's not as if it's an either or problem, it's just a timing. And it's about the ratio of in every sprint what you do, which work is on tech debt or on documentation, which work is on actually doing new features. And so having teams follow the rituals of greater agile, whatever way you call them, of retrospectives and trying to improve your process, I think is really important. And there's a lot of sort of in data and analytics, there's a lot of waggle, there's a lot of fake, people do sprint, dev sprint, STEM sprint, QA sprint, just like in software. And so I think that's a, I think that's a good question. And